Welcome to Totally Integrated Instrumentation. In this blog, I'm going to have a look at Profibus PA, quick introduction, some of the hardware concerns, and we'll finish off with some of the tools that we can provide to help you design your Profibus PA network. Profibus is a digital communication platform. And if you think of it as a book with many chapters, and each one of those chapters might be something like Profibus PA, Profibus DP, Profibus over Ethernet, which is referred to as Profinet. We have ProfiSafe, ProfiDrive. So there's many chapters within this book, but it all comes under the umbrella of Profibus. But Profibus as a whole, it has some nice features. So the way it presents the data is uniform across all of the chapters in the book. So if we're looking at something like a level sensor, a flow meter, a pressure transmitter, we get a floating point double word. So that's real. So we don't have to do any scaling on it. That is going to be reading the process value from the instrument. So we don't have to do any scaling in our PLC or DCS. And then the nice bit at the end is something called a status byte. So this is all the error code information contained within the instrument, transmitted in a uniform manner. Right? And this is the information that tools like Somatic PDM will look at. When we come to Profibus DP and PA, which will make more sense what these are in a minute, we use cyclic communications. So you'll have somebody come to you and say, right, okay, you can put 130 instruments, 120 instruments onto a Profibus network. That's right, but you have to take into consideration that you've got to cycle around and communicate to all of those devices. So the more you have on, the greater your cycle time. So having smaller networks with fewer instruments on will keep your update times up. The other thing you need to be conscious about, within that cycle time, there's a slot reserved for what we call acyclic data. So if an instrument puts a fault onto the bus, we get a status byte error. Our communication software will carry on working with its cyclic data, but we need to diagnose what the error is in more detail using a maintenance station type tool, and we don't want that to interfere with the cyclic communication, because that is what's controlling your plant. This acyclic slot is where PDM, Somatic PDM, will communicate to the device and get the diagnostic information. So if you haven't engineered your network correctly and you put too much instruments on, or you've added instruments without recalculating your cycle time in your PLC or DCS, it can affect that acyclic data gap, and we can have communication problems with PDM. So we're going to move our way down this diagram. So the first one we're going to look at, the first communication network, first chapter, is Profibus DP, which stands for decentralized peripheral, and that's based on a physical layer of RS485. So that transmits a plus and minus 15 volt signal. It requires two cables. We have to be careful with termination. So what we don't want to do is just leave the end of the network with no termination, because you'll start to get bad communication reflections coming down the cable and it won't work. So we always need this end of line terminator within our design. And if you look at RS485, it is designed to be what we call daisy chained, which I'm showing you here on the left hand side. If you break that cable, say here where I'm showing now, you may think that you're just going to lose all of the instruments after that cable break, but unfortunately you've now removed the end of line termination resistor from the network, so you could lose the whole of the network. So there are devices on the network that can act as splitters And what that allows us to have is a Profibus DP spur to go off to the instrument separately. So if I lose this instrument or I break this cable, I only lose this connection. And 9 times out of 10, the cable damage is going to happen in the field. So this would make more sense. What I would say is Profibus DP really isn't designed for hazardous areas. I know we can get around it and we can do it, but it's really not what it's designed for. It also doesn't like water. So if you start to get condensation in your junction box and you're affecting that plus or minus 15 volt signal, you'll start to cause issues across your whole network, and that could be the junction box on your instrument not being sealed properly with the wrong cable glands. So yes, you can take it out into the field, but be careful. You'll see this 12 megabyte speed being thrown around. That's okay for short cable runs and networks with a few instruments on. Okay, the more instruments you add, the longer the cable runs that you have, the slower you have to have this speed. Most instruments are restricted to 1.5 megabytes per second, which is still pretty fast, but it's a lot slower than this 12 megabytes that it's stating. So sometimes you want to have your drives running at this speed. So it would make a lot of sense to have your drives on a separate network to your instrumentation, so you have 2 Profibus DP networks. So that's Profibus DP. There's another network that can sit below that, call it a subnetwork, and you can see here it's called Profibus PA, and it's the process automation network. It's designed to put your instruments on. We have a converter here that converts Profibus DP to PA, and for Siemens that's called a DP to PA link. What's nice about this, it's a loop power type system, so it will power your transmitters, so your wiring becomes easier. It supports intrinsically safe. The instruments can be configured over the bus, but it does work at slow speeds, 45 kilobytes per second, which the most time for instrumentation control is more than fast enough. But again, you're going to have the same problems. You'll see that, you know, in some circumstances you can put up to 125 Profibus PA instruments onto one network. Yes, you can do that, but don't forget your cyclic time. You need to be aware of that. So we're going to have a look at the converters. So there's converters on the market that are called transparent couplers, and these tend to be a lower cost way of getting instruments onto your network. So what we have to do, we sit it here in the middle, you can see this, but as far as your PLC is concerned, it can't see this device. It's transparent, hence the name. It can see the PA devices, but it assumes that they are DP devices because it's got no way of telling whether they're DP or PA. So you've got some limitations. The first thing you have to do is you have to slow your DP network down so it can support the PA speeds. So you have to slow it down to 45 kilobytes per second. We're now mixing up 2 network technologies, so our rules become a little bit crossed over. So we do have to be very careful with how many devices we put on our network. Every device that we put here will take an address up on the DP master. So you would think that you can put 130 devices on, but really, because it's a subnetwork, it's working a lot slower. And from experience, if you want to use tools like PDM, we really want to restrict the amount of PA devices that we put onto that network to less than 31. If you want PDM to work really fast, you really want to be restricting that to about 20-ish. It's a very loose rule because we don't know cable lengths and everything else there, but just be careful. If you've designed one of these networks for the first time, you'll see that 130 and you'll think you can just go for it, and then when you start commissioning it, you're going to have problems. We still have to terminate this PA network, which we're going to come on to. So this way is okay. It's the lowest cost way to get on, but it could cause you issues as you go further on in time and you want to add more devices to your site. So really, the more flexible way to go is to have something called a DP PA link coupler. So this now has two cards, and what we have here is we have a DP slave, Profibus DP slave, but a Profibus PA master. So this is communicating to all your PA devices, and you'll have all of your separate addresses there for PA. But now we only take up one address on the DP network because it's only one DP slave. It also means that we can run the DP network at its full speed. We don't have to slow it down because we've separated the two networks with this device. There is one limitation, and it's the amount of bytes. So this header module here can cope with 244 bytes, which sounds a lot, but if you start putting things like Coriolis meters on there where you've got multiple process values, say if you want to bring back flow, total, density, temperature, each one of those is 5 bytes. So already you've lost 20 bytes from one instrument. So there's a lot of programs on there that will do, available. There's a lot of programs available that will do your network design mechanically, but they don't take that into account, the bytes that are actually coming back to your master. So just be careful of that. This PA coupler, there is a hazardous area version of this available. It's restricted to 90 milliamps, and you can see here the non-ATEX version is 1 amp. Okay, most instruments draw about 14 milliamps. You have to be careful. You have to take into consideration when you're designing your network the fail-safe current of some of those devices. So you do need to leave some spare capacity. But straight away you can see with this EX version that if I'm drawing 14 to 15 milliamps, I'm restricted to no more than probably 8 or 9 instruments on that one network. Definitely not 10. So I would have to add another EX coupler. Now I can put, I think it's up to 7 EX couplers on one link. Okay, but I've still got my 244 byte limit. So there's a lot to take in there, but it's worth to know that really this is the most flexible way to go, because if you do need to add another network at another day, I can just add another link coupler to my network and I don't have to worry about what's happening to my DP side because I'm only putting one address onto that network. So Profibus PA itself is a very flexible network, and it really can be wired up as neatly or messy as you want. And they have given this different names, bizarrely. So you can see here we have a star, we have a tree, but really the best way to wire it is what we call a trunk. So you have one cable going around your site. At the end of this cable you would have an end-of-line terminator, so just one, and then we would have spurs going off to your instruments. You don't need to terminate at your instruments, you just need one end-of-line terminator at the end of the trunk. That keeps your network nice and tidy. You're only taking one cable around, say, your tank farm and dropping your spurs off. It's flexible with the bus length, so 1900 meters. If you were to compare that to Profinet or Ethernet, don't forget we have our 100 meter limit from each Profinet device. So this is a lot more flexible, and it's still powering the instruments over the bus. So if we have a look at our layout, you can see there we have a trunk. We need a terminator at the beginning of the trunk and a terminator at the end, and then we can drop our instruments off if we want with standard junction boxes. Okay, we're going to come on to why we wouldn't do that. And if we have an instrument or need to add another instrument, I can daisy chain off that instrument as well. It's flexible to do that, but that is then one continuous spur. So if you add on to it, you need to make sure that your network design can cope with that spur length. Hopefully that makes sense. So I have people ringing me up asking me about these resistance values and capacitance values for end-of-line terminators. Really, the message is go and buy a proper end-of-line terminator. Don't try and make your own, especially if you're working in hazardous areas. So if we have a look at this relationship for number of spurs and the length of the spurs, it's related to the length of the trunk, which isn't really shown on this table, and the amount of instruments. So if I was to look at my hazardous area or a non-hazardous area, for a non-hazardous area, if I can have 13 to 14 spur lines, which is instruments, I can have a spur length of 90 meters. If I come up to here, for hazardous area, it stops at 12 instruments. Well, why is that? If we go back to what I previously said, the IS coupler is restricted, so it can't do any more than that anyway. So you would have to have a separate network for the next lot of IS instruments. So we do have a problem if we use that IS coupler. We would take up a lot of space in our cabinet, which would have to sit in a safe area or a zone 2 area. So to have a look out in the field, there's many ways of doing your connections. As I said, you can just use a conventional junction box, but somewhere you're going to have to put an end-of-line terminator on. We do have to be careful with that. There are things like quick connects. I've seen these used before, and I would strongly recommend not to use them. On a food and bev site, with people with hose pipes or chemical site where chemicals can get in here, they can corrode the blades that cut into the wires. If you've got a lot of them, it's going to be very difficult to find where your cable damage is. We have junction boxes. This is an example from more industries. So this is a single instrument. Your trunk comes in and goes out, and then you have a spur going off to your instrument. There is a version of this for end-of-line terminating. So if you've got to have the end-of-line termination, then this would be blanked off on the right-hand side. There'd be a switch in there to flip the end-of-line termination on, which you've got to do manually, and that needs to sit at the end of your network. So if we have a look at the next slide, we need to have the DP PA link coupler, which converts us to Profibus. So I just spend a bit of time here talking about the colours of the cable. So Profibus DP is always purple. Profibus PA is black for safe area and blue for hazardous area. In this example, we're using the Wiedemann junction box, so we'd need one of those junction boxes for each of those connections, and then we'd need the end-of-line termination version at the end for my last drop off to my spur to terminate the trunk of the network. Inside the coupler, there's another switch which is your termination for the beginning of the trunk. Okay, so hopefully that makes sense. So nice thing about Profibus PA is we have something called the FISCO concept, and I'll try and remember what this is. This is the field intrinsically safe concept, I think. So basically your instrument will say FISCO on it, your coupler will say FISCO on it, so you don't have to start doing the calculations for what barriers are needed and everything like that. Those two FISCO devices are designed to work together with no other hazardous area engineering. As I said, if we're using that hazardous area coupler, we're limited. Spur lengths 1 to 24. Well, we can't put more than 9 instruments on there, so because of the current draw, those can be no longer than 60 meters, and the maximum length of cable in total, so that's the trunk and your spurs, is 1,000 meters. Okay, we need to use the quality cable on this, which is always blue. We would never recommend using different cables. Once you choose your cable, you must stick with it across the whole of your network. But you do have to do these calculations for current draw and bytes and spur lengths and trunk lengths yourself. So there's a bit of engineering to do. So pretty complicated. I can't remember when this came in, but quite a few years back now, Profibus brought out this other method for IS wiring, and it's called the high-powered trunk concept. So first of all, what it allows us to do, on one trunk cable we can have safe area and hazardous area connections. So we don't need the IS coupler now limiting us to 100 milliamps. We can put the 1 amp coupler in here. You have some special junction boxes, which we're going to come on to in a minute, that then give you the protection for different areas. And you can see right at the end here, we have this cable would be in a zone 2, up to this point where it can go into a zone 1, zone 2, and then the spurs that come off are zone 0. But that is all from one high-powered coupler. So your wiring becomes a lot more simple. You can mix hazardous area and safe areas up on the one trunk. What you do have to do, we can't get away from that, you still need to have an end-of-line terminator resistor. So one of the junction boxes, I do apologise for this, I work for Siemens, there's probably others on the market, but this is the one that I'm aware of. It's called the AFD, so Active Field Distribution Intrinsically Safe. And what it is designed to do is designed to sit in a zone 1 or a zone 2 area, and then you have your blue cable glands coming off here. So internally on this, it are FISCO barriers for your instruments. Okay, the spurs are completely isolated from the trunk. So if you accidentally short one of these out, if that was a normal junction box and you shorted the connections out, you would short the whole network and bring the whole network down. If you short this spur, it will only short this spur, and then you get a blue flashing light to say that you've shorted that spur. Okay, so you get some diagnostics, and it supports that, as I said, 6 devices to the FISCO model. So no hazardous area calculations are required for barrier packages. This housing can be used for Profibus PA and Foundation Field Bus because they're both bus powered networks. So if we have a look at our network, what have we got to do? So the first thing, we need to design our network, and this is the most important thing. I quite often go to site and I'm asked to look at instruments on somebody's site on a Profibus PA network. Really the first thing you should be asking for is, can I see your network drawing? You know, before, I don't want to accidentally change an address on an instrument, because if I do that, it could stop your plans. Okay, so each instrument does require addressing. I know that with Siemens, once you've addressed the instrument and it starts talking to the master, then you can't change that address locally via push buttons. You have to use software to do that, because otherwise if you change the address, like I said, it will lose the data going into the DCS. So we need to do that. That needs to be shown on the network drawing. And then we need to calculate the spur lengths. So, you know, that's going to be a mechanical issue, you know, because we need to get the cable maybe to the top of a vessel or somewhere else. We need to know the trunk length. So how long is this black cable? And then we're going to need to know the current draw for each instrument. And then ideally what you want to know is the fail current. Now, if you looked at a Siemens DS3, it says the fail current is 0, so it doesn't add any additional current on if it fails. But there are some instruments where they add 3 or 5 milliamps on to your current draw. So you have to be careful. Now, you're not going to have all instruments fail at the same time, but you need to make sure that your network is designed with some capacity in there. Okay. So this is a network with the AFD junction boxes. So if we'll have a look here, this animation, what it's showing is the AFD junction box automatically terminates. So if I add devices to it, my termination will move, so I don't have to worry about flipping switches on, going to site and thinking what junction box is at the end of the trunk. On a drawing it's easy to see, but when you're on site it's not so easy to see, unfortunately. All instruments, Profibus instruments, are shipped out with a default address of 126. So the addresses, so this is when you're on site, all of these instruments are going to need configuring. Instruments that haven't got a display or dip switches to set those address, you're going to have to use a software tool to do that. And PDM is one of those tools, Somatic PDM. If you've got them all at address 126, well, and none of them have got displays, then you've got a problem, because what you're going to have to do is you're going to have to disconnect all of those instruments, connect one at a time, change the address, change the tag, add another one, and that on a site, say with about 50 instruments, could take the best part of a day. So you're going to be losing quite a bit of engineering time there. So you do need to be careful. And again, you would require the network drawing for that. You can't guess, because if you need to make sure that you're setting the right address, because the person writing the PLC code or the DCS code needs to be making sure they're getting the right information. Okay, once the plant's up and running, this is normally where I get contacted, where somebody says, "Oh, I've had this Profibus PA network and it's been working, and the plant has grown, so we've added more instruments in, and it's grown over time." And then normally what starts to happen is you start to have communication issues, because at the top, the first thing you haven't done is you've added these instruments, but you haven't recalculated your cycle time, your cyclic data time. So that needs to be done. But most commonly what happens is we have to get a certain bit of plant up and running quick. We don't check the network design to make sure that it can actually cope with the additional instruments that we're putting on. Okay, so this is where we need to be careful. Okay, I just wanted to put this slide up because we've been talking about the hazardous area. So the AFDIS, the part numbers are here. I will put the links for all of these part numbers in and devices within this blog, and if there's any additional information I'll put it in the comments field. So we have a 4-channel safe area. When we say safe area, that's zone 2, and then we have an 8-channel safe area, and then we have the 6-channel AFDIS. What you haven't got on here, and I will do a video on this at a later date, there is a version of this called the AFDIS-D. So all of these at the moment don't require GSDs. They're completely transparent as far as the DCS PLC is concerned. It's hardware, clever hardware, but that's what it is. But there is a version, like say on hazardous area 1, with a D on the end, little switch, where you can turn on some diagnostic information. So you can disable spurs, you can look at the current draw, jitter, things like that on here via PDM to see how good your communication is on your network. Right. So thanks for listening. I hope that was informative. A look at Profibus PA networks. What we're going to do over the next few weeks or months, depending on time, is I'm going to do some practical examples of how to integrate Profibus PA devices into TIA Portal and PCS7. So thanks for listening. Your support is really appreciated, and I hope it was worthwhile. Thanks a lot.